All right, I've had this question here. It's about, this is the one apparently out of the Calculus PEA5 Question 3e book. I have the book at school, I don't have it at home, so this is the question though. It says a cylinder of height h and radius r is to be fitted into a sphere. The sphere's diameter d. And says, show that for the volume of the cylinder, the maximum, blah, 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 blah. Okay. I'm looking at this, and I think there's some really interesting stuff about it. First of all, the only thing that the cylinder has to do with anything is the fact we've got a radius. And the radius just happens to be also the diagonal of the cylinder. So my first inclination, on face value, is to say ignore the sphere. It's got nothing to do with the sphere at all. It just happens to be inside the sphere. In fact, for me, I actually treat this as a circle with a cyclic quad in it. Cyclic quad, of course, being any quadrilateral that will fit inside a circle. So what I see is this. That didn't work out too well. Cyclic quad, in other words, a quadrilateral. These are all right angles, of course, being a rectangle. And we've got a diagonal here, which we're going to call D, which happens to be the radius, by the way. But really what it is we can ignore the whole of this circle. It doesn't really play a part as far as I can see, because we're not asked for anything other than the cylinder and the diagonal. So I would treat it not as something inside a sphere, but just the diagonal of a rectangle. That's as a two-dimensional. As a three-dimensional, though, it's obviously inside a cylinder. Here, yeah, as such. And it just happens to be the bit across, so I can go from one corner to the other side like that, and there's my diagonal. Now, in looking at this, what I see is a triangle. I've got a triangle, because all we've got to do is we've got to fit D into the equation here. And D isn't part of this equation. But if we can put it in terms of D, ultimately the answer has to be in terms of H, but we need to insert D somewhere into this. And if we think about it as a triangle, well, we can, because we know that if this was just a triangle, and a right angle triangle at that, we know that D squared must equal, and I'll call this A here, and let's call this B over here, must equal A squared plus B squared. And that's as much as we can say. Now, we do actually know what some of these things are, because we're told that the bottom here, across here, is actually going to be, well, half of it's going to be R. So the whole thing, of course, would be 2R. Sorry about the dog barking. Oi! Stop it! Crikey, what do you do? Okay, so let's call this bit along the bottom here, this A bit. I'm just going to call it 2R. So we've got D squared is equal, it's going to be 2R all squared, plus, and B, of course, is, well, that's the height, yeah? That's height, so I'm going to put height over here, height squared. Now, let's go and have a look at the equation we've got. Well, we know the volume is, and notice that we've got to find, it says show that the volume of the cylinder to be a minimum. So it's the volume that's changing. It's going to be, if we're going to have a volume equation, we're going to differentiate with respect to volume, because it's the volume that's going to be changing. So I'm going to try and insert this into this thing here, into volume. Well, we know that volume is pi r squared h. Now, we've got an h squared here, so we could actually make h the subject. That would work if we just found the square root of everything, made h the subject. We're there, and we'd have a d in there. But I'm looking at it, and I've already got, if I just keep it as it is, I've already got an r. I wouldn't have to find the square root of both sides. I would if I had to use h, but I wouldn't if I have to use r. So let's just tease this out a bit further. So this becomes d squared is equal to 2, actually here, let's go 4, because 2 squared is 4, r squared plus h squared. So I can actually make h squared the subject simply by subtracting 4r squared from each side. There we are. So h squared, oh wait, sorry, sorry, I'm doing it the other way around. I'm going to do it the other way around. I don't want h squared. My first inclination is to use h squared. Let's use r squared. Yeah, that's definitely the best way of doing it, I think. So here we go. We're going to have d squared, equals 4r squared plus h squared. So I'm just going to subtract h squared. That's the best way. Subtract h squared. Sorry, I'm teasing this out as I go along. So h squared is on the other side now. I'm going to have 4r squared is equal to d squared minus h squared. Now I just want r squared, because the moment I've got r squared, I can put it straight into my equation here. And then all I have to do is differentiate with respect to v, and we're most of the way there. So let's divide both sides by 4, divide all this by 4, and now I've got myself an r squared, which is d squared minus h squared, all on 4. All right, so I'm going to use a separate sheet of paper there, because I'm just going to tease this out. I don't have enough room here. So here we go. So I'll keep what I've got, and I'm just mindful that somehow we're going to have to differentiate and then just make h the subject, which is really what all we're doing here. So let's do that now. So we've got r squared is equal to d squared minus h squared, all on 4. And we've got v is equal to pi r squared h. So the r squared, I'm just going to put all of that. That's me meant to be drawing an arrow, right? Sorry, there's my arrow. All of this is now going to be r squared, yeah? All of this. Can you believe that's meant to be an arrowhead? All right, so this is terrible. Okay, so here we go. So v is equal to pi, I'll go pi h times all of that. So d squared minus h squared on 4. There it is. So I'm just going to, expand the bracket. So here we go. I'm going to have, that's fine. So I'm just going to go pi h d squared minus pi h cubed, and they're both going to be on 4. This is going to be on 4. This is going to be on 4, and that's equal to v. All right. So now I think that's a reasonable expansion. Let's check that. That looks a bit weird. Oh, that's why I'll put a d squared that way around. Now I want to use a small d, by the way, because I'm going to be differentiating. So here we go. So I'm going to differentiate volume with respect to. Now I'm going to do it with respect. I'm looking at what I can do here, and the h, I've got h cubed here, and I'm looking at the answer here. We need an h, so we want to reduce the powers of h by as much as we can. So I'm going to be differentiating with respect to h. So dv with respect to h is equal to. So the first one here I've got. If I was to reduce the h here, I'm going to reduce h here by 1. So I'm going to just simply go crossing it out. So it's going to be pi d squared on 4. There it is. That's differentiated. I've just got rid of the h. I'm going to reduce the h here, so I'm going to have, so it's going to be 3 pi h power by 1 all over 4. And it says that we want the whole thing, it says, to be a maximum. So I need to make it equal to 0. So here it is, 0 is equal to, all of this, which is pi d squared on 4 minus 3 pi h squared on 4. Well, I can just multiply everything by 4. That's my first inclination. That would get, because we want to get rid of the denominators. So this be 0. In fact, I'm going to multiply this by 4. I'm going to multiply this by 4. So I'm multiplying this by 4, this by 4, this by 4. And of course, 4 divided by 4 is 1, 4 divided by 4 is 1. And of course, 4 times 0 is still 0. So 0 is equal to, and I've got pi d squared minus 3 pi h squared. So now we wanted to make, this looks a bit easy now, because we want to make h the subject. So I want to end up with, I'm going to write this down over here so I can see it. We want h is equal to g. I'm just going to write this down. I'll show you in a second. So I'm just writing this down the side here because that's my goal. So all I've got to do is manipulate this so it turns into that. And the first thing I'm going to do is actually make h the subject. So I'm going to add this thing here to both sides. So I'm just going to add 3 pi h squared plus 3 pi h squared to both sides like that. Yeah. So this now disappears, and I've got 3 pi h squared is equal to pi d squared. All right. So first thing, divide both sides by pi, actually. If I divide this by pi and divide this by pi, the pi's disappear. I'm going to divide both sides by 3. I'll divide this by 3 and divide this by 3. So I'm left with h squared is equal to d squared on 3. So remember, this is our target here. So now I can see if I just find the square root of both sides, if I find the square root of that side, it becomes an h. If I find the square root of d squared, it becomes a d. And if I find the square root of 3, it becomes root 3. And there is my solution. So that's what I do, folks. It's really as much an algebra problem, it seems to me, as anything else. You could have gone the other way, though. You could have gone, there's nothing too wrong with going, well, let's make h the subject and insert h into this here. But to do that, the only problem is you're going to have to find the square root of this and this and this, and you're going to end up with a square root in there. And the only way to undo all of that is to square everything again, and now you end up with some things to the power of 4, because a square, something that's already squared, which then you square again to get rid of the other square roots, is now to the power of 4. It would be a little bit messy. I would tend not to do it that way. This way seemed to work out, and hopefully that makes sense.